20 square minus 30 times 20 plus 60. Here will be 400 and this will be 1,200 minus 600 plus 60. So when you subtract, it will be 600 plus 60. We get 660. So here the marginal cost is this one. So you can compare when you produce 30 units, the marginal cost is what? Is 1,860. And here the marginal cost or the additional cost is 660. So in this case, it means when you increase 1 unit of output, the additional cost will be very, very high. So in that case, it doesn't make sense to increase output since the additional cost will be too large. You are asked to calculate the output the firm should produce to break even. When we say break even, it means here the firm earns only normal profit. So break even means a firm or firms earn normal profit. Now, at this we said if the firm earns normal profit, it means the average total cost will be equal to price, or price will be equal to average total cost. So the firm is at a break even. Now we said at a break even, the average total cost is equal to price. So the average total cost, which is Q cubic minus 15 Q square plus 60Q plus 128 over Q, should be equal to the price, which is 660. So when you multiply Q cubic minus 15Q square plus 60Q plus 128 will be equal to 660Q. So collect like terms. So solving this cubic function, the result will be as follows. So now you can solve this function, the cubic function. Our function is Q cubic minus 15Q square minus 600Q plus 128 equals to 0. So when you solve this cubic function, you'll get 3 units of output. The first Q will be equal to 33. The first unit will be 33.04 units, and the Q2 will be equal to negative 18.25 units, where the negative does not exist. And the third will be equal to 0.21 units. So the firm will produce at a break even if the output will be 33.04 units and 0.25 units. So therefore the output at break even is this one, which is 33.04 units and 0.21 units. So this is how you can calculate the break-even output. The fifth case, we are asked to calculate the minimum cost. So the minimum cost. So we know our total cost function is Q cubic minus 15Q square plus 60Q plus 128. So this is our total cost function. Now we are asked to calculate the minimum cost. We know that the minimum cost occurs when you differentiate the the total cost function and you equate equal to 0. So when you find the marginal cost, so marginal cost will be equal to dTc over dq, which equals to, when you differentiate, this one will be 3q square minus this one will be the same as a 30q plus 60. So when you differentiate this cost function will be this one. So the same as the marginal cost, which is equal to 3q square minus 30q plus 60. So this one will equate equal to 0. So when you solve this marginal cost function, this is a quadratic equation, so use a calculator or use the general formula to solve this one. You will get Q1 so Q1 will be, so when you solve this quadratic equation, Q1 will be equal to 7.24 units and Q2 will be equal to Q2 will be equal to 2.76 units. So solving this quadratic equation will get two values. So now here you need to find which output minimizes the costs. So in order to find the value which minimizes the cost, you need to find the second derivative of the marginal cost function. So here you need to find the second derivative of the total cost. So when you differentiate this marginal cost function, so the marginal cost is 3q square minus 30q plus 60. So when you differentiate, this one will be d square of the cost over dq square will be equal to 6q minus 30. So in order to find the minimum cost, when you differentiate the second derivative, this one should be greater than 0. So the d square dtc over dq square, this one should be greater than 0. So here is our critical values. Our critical values. Which we obtained when the cost is minimized. So you can substitute these values in this equation. So when you substitute there, for the case 1, d square dc over dq square, this will be equal to 6 times, let us start with q1, which is 7.24, then you minus 30, 43. So you minus 30. So when you take 43 minus 30, you take 43 minus 30, here will be 13.44. So you can see the d square tc over dq square is 13, which is greater than 0. So this one will be the minimizing level of output. So the output which minimize the cost. So let us substitute this in our equation. When we substitute 2.76 d square tc over dq square, this one will be 6 times 2.76 minus 30. So when you use your calculator, 6 times 2.76, then you less 30, I'll get negative 13.44. So you can see that this is less than, or is negative. So if it is negative, means that will be less than this. So that one does not minimize the cost. So d square tc over dq square, this does not minimize the cost. So if you ask to calculate the minimum cost, means our critical values, or our critical value to substitute this one. So substitute this value in the cost function. The minimum total cost function will be equal to q cubic minus 15q square plus 60q plus 128. So when you substitute, the value will be 7.26 7.24 cubic minus 15 7.24 square plus 60 times 7.24 plus 128. Result will be 155.64, which is approximately equal to 156. So the minimum cost, the minimum cost is 156 shillings. So this will be our solution. So you can also try to substitute when the output is 2.76, what will be the cost? So in this case, our cost will be this one. So this will be the minimum cost, 156 shillings. So thank you for listening. This is the end of our discussion. Next we'll meet to discuss another type of.
Elimu inaendelea na vita inaendelea dhidi ya ugonjwa wa corona. Watu wenye ulemavu wanasemaje? Faraja Jeri ana changamoto ya uoni.
Napenda kuiomba jamii iwalinde watu wenye ulemavu wa macho dhidi ya kirusi corona.
Sofia Mbehela ni mwalimu na mjasiriamali.
Mapambano haya ni yetu sote. Tuwalinde watu wenye ulemavu dhidi ya corona. Stay safe.
Akashi Mtenda au Zungu la Da anatoa elimu.
Kusalimiana na desturi, habari yako mkuu, habari yako, salama, kwema, tusigusane wala tusikumbatiane wala tusipigiane mabusu.
Tutumie mbinu zote kukabiliana na corona huku tukifanya kazi kwa bidii. Yohana Mwila ni dereva wa bajaji.
Wakinge walemavu na corona.
Sisi ni jeshi la ushindi. Nawa mikono, vaa barakoa, tumia vitakasa mikono, epuka misongamano na kadhalika. Tuwalinde wenye ulemavu. Tanzania bila corona inawezekana.
You are watching Darasa Online.
Hello my dear students, welcome to our Darasa Online. It's once again physics. My name is Mr. Samuel John. In our previous discussion, we talked about the transistor in the topic of electronics. So we had a topic. This is our electronics. And I told you before that we'll be having the second part of it. So it's now the subtopic of today is a transistor. As a switch. And if you remember, we mentioned that transistor can be applied in different parts of our life. One of the application is you can use transistor as a switch, security systems and alarm system. So before we start this part of the transistor as a switch, let us remind ourselves of what we discussed in the previous part 1 of this topic. And as we start, let's have this as a start. The question says, in an NPN transistor, the input voltage is 5 volts and the base resistance is R1. If the load resistance is R2, such that the base and the collector currents are 0.2 milliampere and 10 milliampere respectively, negating the base emitter voltage. So this is the information that we're given. We want to test whether you remember what we discussed in the previous subtopic on the transistor. The question says, part A, calculate the value of R1 and R2, given that the voltage across the collector emitter is 5 and the voltage across the collector supply is 10 volts. That's part 1 of the question. Part 2, and if we change the value of R1 and its values adjusted to 2.5, what will be the values of IC? Step number 1, you are supposed to draw the diagram representing the above the information. So let's start drawing the circuit diagram for this question. This is our NPN transistor. NPN. So this is the question says we had the load resistance, which is R2. That's where you have R2 here. R2 here. This is our supply voltage. And we're given this is R1 as the input. This is our input voltage. This is the base current, because this is the base, this is a collector, this is our emitter. And this is our collector current, of course. So we have the circuit as required. You're supposed to have the complete values. The values are provided information. From the information, we know that VCC, this value is equals to 10 volts, and the voltage across this. So here, that's why we have this voltage here is VCE equals to 5 volts. The voltage across that junction here, and this voltage here, we are told to negate. So it's supposed to be VBE. We are told this is approximately equal to 0. It's very small values, and we are told to neglect that. So we are given the input voltage here as 5 volts. So the base current and the collector current are given. So base current IB is given as 0.2 milliampere, which is 0.2 times 10 negative 3 ampere.